Hey everyone, and welcome back to the EdgeVerse Tech Cast. As always, this is your go-to place for everything NXP software, tools, and enablement. I'm one of your co-hosts, Kyle Dando, and today, I've been told we're doing something a little different.
A little different and a lot more fun. Hey everyone, I'm Bridgette Stone, and today, Kyle, you are officially a contestant on The Dating Game.
What? Maybe when I was younger, I was looking forward to this, but I don't know. I don't know if I'm prepared for this, Bridgette.
Oh, don't you worry, Kyle. We've got 3 great matches lined up for you. The only question is, will you pick the right one? And we're not doing this alone. We've teamed up with one of our platinum partners, PhyTec, who builds system on modules powered by NXP processors. Joining us today is True Lone. Yes, that's his real name, applications engineer at PhyTec, and he'll be helping us break down what's actually happening behind the scenes, especially when we get to our final door.
Well, unfortunately, I am old enough to actually remember watching the original Dating Game, and I don't think you and True can say the same thing. But you know what? How hard can this actually be? Hopefully, you guys recruited some fascinating options for me to take on a development date. But now, back to this True fella. So you say he knows all the answers, and I'm just here guessing? Bridget, that does not seem fair at all.
Oh, it's totally fair. True and I had this cooked up in the background, so no pressure, and let's get into it. All right, everyone, welcome to our throwback edition of The Dating Game. Here's how it works. Our partner PhyTec has lined up 3 eligible computing platforms, each hidden behind a mystery door. Each one is going to introduce itself the way embedded systems do best. A version of Hello World with a blinking LED, or should I say winking LED. And after each demo, Kyle, you'll have to guess which NXP SoC is behind the door. Sound easy enough?
That sounds like famous last words, but you know what? Let's do this thing. Bring on the contestants.
All right, Kyle, let's start simple. What's behind door number 1?
Hello, I'm Mystery System 1. I am programmed to blink an LED using a SEGGER J-Link probe that is then connected to a PC. My firmware is compiled and built in VS Code. Debugging is made really easy. You can use GDB to walk through each line of the code. As you can see, I am using the pin right command to control the LED on and off in real time. Just using 4 lines of code here. Since all of these commands are placed in a while loop, when running the whole firmware together, I can act like a heartbeat, fluttering on and off.
Classy, clean, no drama. What's your guess and why, Kyle?
Well, Mystery System number 1, I must say your heart wasn't the only one fluttering when you mentioned that you were into VS Code. I also love a good debug session using NXP's MCU Expresso Visual Studio Code extension. So, we at least have that in common. But you know what? Your description sounded like real-time control of an LED by maybe one of our Cortex-M microcontrollers. Maybe you are one of NXP's attractive new MCX microcontrollers. You have me very curious. I would be very excited to find out more about your ability to turn an LED on or off.
Ooh, all right. Well, thank you, Mystery System number 1. On to door number 2. Let's raise the stakes. What's behind door number 2?
Hey, I'm Mystery System number 2, and I have a connection to a PC, so I have a console, and I can log in with root and manually blink an LED by echoing 255 or 0 to sys class LEDs blue user 3 brightness. Now to blink a cadence, I can echo heartbeat to sys class LEDs blue user 3 trigger.
A little more going on here, Kyle. Maybe a bit more personality. What are you thinking now?
Well, Bridget, you know, Mystery System number 2 definitely sounds like they may have attended some engineering classes with me in the past. I would say we have more of a connection than a simple PC console. How you described sys class makes me think you may spend lots of your time hanging out with the Linux community. I'd be interested in figuring out more about this mystery platform and how open you are to that.
Ooh. All right, final door. What's behind number 3?
Here we have our third mystery system booted into Linux. We're going to log in as root, and first we're going to kick off some LEDs here in the Linux domain using the sysfs interface. Next, we're going to utilize remoteproc to first tell our microcontroller what firmware to run, and then we're going to start that microcontroller. Now we can see that we have LEDs in the Linux domain blinking alongside the LEDs in the microcontroller domain simultaneously.
Okay, Kyle, now things just got very interesting. Final answers. What's behind each door?
Wow. Bridgette, the third mystery platform sounded like it may have had a split personality. Platform number 3, you mentioned Linux and the sys class. You must be close with our platform number 2 contestant. But then you surprised me with mentioning microcontroller. How on earth are you able to offer me LED control with both Linux and microcontroller software? You have me stumped. But you know what, Bridgette? Here are my final answers. All right, so door number 1 is obviously that MCX MCU I mentioned. It's running a Blinky LED program from the MCU Expresso SDK. Such a reliable software package. Now, behind door number 2 was a little trickier. It's a platform with an edge, and that edge is Linux, and that's easily run on our i.MX application processors. And finally, like I said, Bridgette, door number 3, this has me a little concerned. Could there be a set of twins back there? One based on an MCX microcontroller and the other based on the i.MX? I think we might need some help making a better decision. So you know what? I think we need to have True help us out here. Maybe he can come in and help the listeners better identify what platforms are behind all these mystery doors.
All right, very, very good try, Kyle. So that third door clearly had a little more going on than a typical Blinky, and that's exactly why we should bring in True, the engineer behind these different mystery platforms. Joining us now is True Lone from PhyTec. You were the one who helped make the platforms in the dating game possible. True, welcome to the show.
Hey folks, thanks for having me. I'm an applications engineer at PhyTec, and you just heard my coworkers Maddie and Sierra in those short videos just a moment ago behind doors 1 and 2. As an applications engineer at PhyTec, we kind of drop in everywhere. Our main goal is to help out our customers get their products into production and keep them into production. Most of my time is spent working with customers debugging or to test new ideas. The NXP i.MX 8M Plus, or i.MX 8MP for short, is one of our top sellers at PhyTec, and it is because it is so versatile. The examples we run today here are all things I've helped people learn to do on this platform and before.
So True, you mentioned that door number 3 was actually the i.MX 8MP. You impressed me with how versatile it can be. And you were able to fool me into thinking the first doors might have hidden our MCX MCU and i.MX MPU compute platforms. So now that we've resolved all the mystery, why don't you tell our listeners why a system architect would want the MCU and MPU on one device? Why is that kind of hybrid approach becoming more important?
Well, that's a great question, Kyle. We see a really big trend in consolidating systems, and it really makes a big difference when it comes to maintenance. Typically with your SOM vendors, you hear a lot about rapid time to market. Don't reinvent the wheel, just focus on your application, expedite power, RAM, yada, yada. All these things are common to most embedded electronics design. So that's a really big reason why you'd want to use a SOM, saving that headache when it comes to maintenance. A big chunk of your BOM is managed by your SOM vendor. And so here at PhyTec, that is what we spend most of our time doing, just to keep ensuring that our customers can ship products for 10, 15, honestly longer, for up to 20, 25 years in some cases. This is why we like NXP, given their product longevity for their processors, PMICs, and connectivity devices.
Okay, so NXP and PhyTec provide customers with a solution fast, and having them on that single platform, as you mentioned, can reduce maintenance nightmares. But now they have your SOM solution. What other benefits do they have with the i.MX 8MP having both that MCU and MPU on board?
Yeah, so that goes back to your original question on why are we consolidating systems with both an MCU and an MPU on one chip? It's a lot easier to manage one than two. I'm lucky in my role to interact with so many people designing products, and I honestly just see a mix of this and approaches to it. Sometimes there are teams of software engineers or one team that focuses on real time, and another team would focus on Linux. And if you're lucky, you have a team that bridges the two. Other times I see the complete opposite. It is one person that does everything, and I mean everything, schematic, layout, real-time, and Linux. And I really try to help each person with their unique needs. So for this demo, I've worked with a couple of customers already, set up an application guide. In this case, we really meant for someone coming from MCUs to this new dual brain system, given their application requirements and complexities.
Okay, so it improves the collaboration with the teams that you work with to merge that real-time software with Linux inside of their products. And it sounds like that application guide is really helpful for getting them all on board. And in this case, you said you have even helped that one person that would possibly want to manage both and put everything in the solution themselves. So it must be a pretty good application guide. So now with PhyTec's SOM solution for NXP's i.MX platforms, I'm assuming that it's the same benefit across the platform, whether it's the i.MX 91, i.MX 93, or the i.MX 95 series. Is that true?
Exactly.
Well, this episode seemed scripted for a perfect date, the evaluation of PhyTec and NXP. Can you tell our listeners the best way to get started with the PhyCore i.MX 8MP dev kit and the JTAG expansion board, True?
Absolutely. Right on PhyTec's website, you can just go shopping cart style and purchase a development kit, the necessary accessory kit that gives you this expansion board that allows you to connect the JTAG debugger. And then you can find our application guide right on PhyTec's developer wiki.
Perfect. So Bridgette, you and I, we can put those links that you provide, True, into the episode notes. Those listening, I would definitely take advantage of it. These contestants and these solutions from PhyTec are definitely worth evaluating. So today's takeaway, if you didn't enjoy the dating game, what we were trying to get across is you don't always have to choose between an MCU for simplicity and an MPU for flexibility. Sometimes you can bring both together on one platform. And with the right tools and the right partner, it's more accessible than you might think.
Exactly. And honestly, I think Kyle learned a very important lesson today. When in doubt,
always pick door number 3.
That's right. And a huge thanks to True for joining us and to PhyTec for bringing the game to life.
Yeah, thanks for having me, guys. This was my first time getting a Blinky demo to get me picked on a dating show, so it was a new one for me.
Yeah, I don't think I've ever evaluated 3 contestants that are all just doing a Blinky demo. Now, for our listeners, if you were impressed with this podcast, and if you want to try this out for yourself, check out the PhyCore i.MX 8M Plus, the JTAG expansion board, and the Cortex M7 development guide that we're going to put the links in the show notes. It was a great example of how PhyTec, along with NXP, can come together to simplify your development across both real-time and Linux environments.
Thanks, everybody, for tuning in to our throwback of the dating game, and we'll see you next time on a future episode of the EdgeVerse Tech Cast.